All right, so let's go over this. So, tell me, what's JSON? Okay, well, that's what it stands for. What is it? So, string-based representation for objects. Could also, is what REST APIs typically send as responses. Something along those lines. All right, what's an API? Okay, so this is a way for us to interface with third-party applications and bring their data into our applications. Third-party, we'll probably say third-party apps and data sets and bring their data in. Well, let's just say apps. I talk about bring their data and bring their data into our applications. All right, so what's REST? Okay, so what is when we say we have a RESTful API? What do we really? What's REST indicate about that API? That's what an API is. Specifically, what's REST? And how does it differentiate itself from our last one, which is HTTP?
Oh, REST is built on HTTP.
Well, that's going to be what we say for. So we're going to say that this guy is a standard for communicating with APIs based on the HTTP protocol. That's what REST is. And what's HTTP? So this is hypertext transport protocol, and it's the language that web browsers and web servers speak. So when we request stuff from when a web browser asks for information from a web server, it's going to use HTTP. That's the language it's speaking. We're speaking English. It's speaking HTTP. Okay, and the web server will respond back with HTTP. All right, so those are those four things. JSON. This is how object information is packaged in a string format and sent over the internet. API is the generic way of us getting third-party application data into our applications. REST is a modern standard that most modern APIs use, and it's built on top of the HTTP protocol, which has been around forever and ever and ever and tested. And then HTTP has also been around for a long, long, long time, and this is the language that web servers and web browsers speak to each other. Okay, and now also the language that our applications and RESTful APIs speak to each other. So we can probably add that to this too. More modernly, or more recently, it is the language that our applications and RESTful APIs communicate with. Make sense? All right. So, questions about any of that? Remind me, this would have been fair game for quiz 2. HTTP 4 functions. What were those? Get, post, put, delete. Okay, what does get do? Reads information. And we can go ahead and say this is the default request a web browser makes to a web server. What is a post? Actually, I'm going to update this slide a little bit. I'm going to say HTTP for REST. So, because we're going to define these functions in terms of how they interface with RESTful APIs. So, post does what? Creates new data at an endpoint. So let's say creates new data on the third party app. You know, so maybe it's a way for, if we're talking about Yelp, maybe it's a way for us sending a new user review or something like that to Yelp, where we're updating their data, we're adding something new to their data, we're adding a new user review. All right, what's put do? Updates existing data on the third party app. And what does delete do? Delete. Deletes. Oh, that's deletes. Existing data from the third party app. Are APIs useful? I thought I was missing. I thought it was, I'd like opened it or closed it and I was gonna just have to keep turning it and then it was gonna come out of the top. This is another example of travel hacking. So I bought this years ago and it's got this little chip. This is from a cruise ship. You can pay for the soda package. There's a little chip on the bottom that you put on top of the soda machine and it detects that you have the package. It doesn't link to your account. It just validates this is a soda cup from this cruise line, so I can use this on any Royal Caribbean cruise forever and ever and ever. But yeah, in the very bottom, there's like an RFID chip inside there.
There you go.
$12 a day. Probably, but it just gives you access to the soda machine, not their whole package. Because you also get like fancy coffees and juices and stuff like that. But if you only want access to their automated soda machine, that's the golden ticket. You know, I haven't tried that on other cruise lines.
It's funny.
Because I assume that they all are buying kind of the same, you know, but I'm guessing they probably have their own code set. Well, anymore, you don't even know what's the enemy because it's just like, you know, like your cereals. When you walk down the cereal aisle in the grocery store, you have all these different things. They're all like under, I think General Mills probably makes like 99% of those cereals.
Yeah.
You know, it doesn't even matter. It's Kellogg's, whatever. That they're all subsidiaries of General Mills. So I think Carnival Cruise Line is in, you know, that's the top tier of like 25 other cruise lines, and then you have Royal Caribbean as the top level. That might be kind of it. That's Nike, Reebok, right? Is Reebok even a thing anymore? Is it cool anymore? And no, people don't wear Reeboks. Have you heard of Reebok?
Heard of it.
There's Adidas, there's a new cool kid. So Nike's still a thing, right? Yeah. So, but Nike's the big brand. Okay. So APIs really, really, really important.
Yeah.
Because when we create applications, I mean, if you just use a simple idea like, you know, you go to these hackathons, you come up with your own app idea and stuff like that. A lot of times when you have a service you want to write a solution for, a lot of times there's like payments involved in the end, right? So it might be nice for you not to have to invent your own bank or payment system. Maybe you leverage PayPal or, you know, Chase Bank or something like that. PayPal's, you know, a pretty popular one, you know, where people can just pay you, or you want to integrate Venmo into your applications. These guys all have APIs where, you can collect a PayPal payment or a Venmo payment from within your app by integrating their API into your application. Make some sense? Okay, so third-party API, super, super, super powerful and used all the time. And the way you will speak to 99% of them today is using through a RESTful API, which is a standard. Older ones, an older standard was called SOAP. You'll hardly ever, if ever, see it anymore. They're all RESTful today. All right, so I would say in general, RESTful's been around long enough now. I mean, it's been around for many, many years now. That any company that's still around that has data you might want has updated their data communication to REST. Similarly, I think it's going to be extremely uncommon, more common than not dealing with a REST API, but extremely uncommon for you to retrieve data or have to send data to a RESTful API with XML. Okay, so RESTful APIs only indicate that it's built on top of the HTTP protocol. It doesn't necessarily dictate that the communication, the way data is transmitted between the two of them, or the type of data that's transmitted between the two of them is JSON, even though it typically is. I would call it 95% of them, it's JSON. The other 5% are XML, and it's probably closer to 100% JSON. In fact, I can't even remember the last API I interfaced with that was only XML. A lot of APIs that were, popular, they might still have an XML endpoint, where if you have, some like old legacy code with them that they wanted to keep working, they'll still give you an XML representation of stuff, but their default now is JSON. So you have to specifically ask for the XML or use that endpoint or something like that. Okay, so do you have a pretty clear idea of the difference between these guys and how they all kind of work together to solve a problem? Okay, but we use JSON for a lot of different things. We use it to, effectively stringify objects. Okay, turn objects into string representations of themselves, which is a collection of name value pairs. I think I look at, so let's look at, I just want to review JSON real quick. JSON, nuts and bolts. So the top level, so we have the root level is a JSON object. Now, what's a JSON object? A JSON object is an opening curly brace followed by, I think technically, 0 or more name value pairs, closing curly brace. I think it's technically legal for you to have an empty JSON object with no name value pairs in it. I don't know why that would make any sense, but syntactically, I think it's legal. Okay, so that's what a JSON object is. So now, what kinds of values? So I'm going to be fairly simplistic here for the types of values we can send, but generally these are string values, numeric values, JSON values, or JSON array. We all know what strings are. Double quote, something, double quote. We all know what numbers are. Okay. I think it technically supports some other types like Booleans and things like that, but let's just keep it simple like this. So we have string types, we have numeric types, so kind of our primitive types from our languages. Then we support JSON objects. Well, what's a JSON object? This guy right here. Make sense? Now, we also have something called a JSON array. Okay, and a JSON array is, actually I'm going to put it down below because I want to keep specifying up here that the root level is a JSON object. So a JSON array is opening square bracket and then JSON object, again, technically 0 or more JSON objects delimited by commas. So we have a collection of JSON objects. That makes sense? All right, so that's what an array would be here. Again, you could technically have arrays of these other types represented in JSON, but again, keeping it simple. Typically, what you're going to be working with is either an object with a bunch of name value pairs, or where maybe one of those name value pairs is a name associated with a collection of other objects. And that's something we've dealt with before, right? Where we think about we have a, I don't know, maybe like from last semester, we had like a fighter class, and inside that we had like a collection of dice for the guy to roll different dice for damage or something like that. But other objects, we might have something that has a collection of other objects. All right, if you're maybe you have a person object, and he has a backpack, a variable called backpack, which is a linked list of tools or a linked list of books, something like that. That would be an object that one of its values would be a collection of other objects. All right, so these are the common things that JSON brings to the table. And really, we're going to say that the JSON array, this is the special sauce. XML didn't have this. That make sense? All right, that could be a good final exam question. You know, yeah, what was the special? So what's JSON special sauce? What did it bring to the table that XML didn't have? Something like that. Okay, so that's JSON nuts and bolts. Now let's go back here. I had Postman up, right? Did we actually see Postman last time, or I just talked about Postman?
A little bit. Yeah, you showed us a little bit.
Okay. Where did that come up? All right, so we're going to create a basic request. Actually, I think didn't I have something open for it? Oh, right. So we'll just review here what I was talking about here at the end. Can we see this okay from the back? Okay. So for instance, I mentioned in the slides here, just to connect the dots, with HTTP, a GET request. This is the default request a web browser makes to a web server. All right, so when I go to a normal web browser here, and I go to www.google.com, that's making a GET request over the HTTP protocol to a web server that lives at Google somewhere. That's a computer with a software application running on it. Common web servers like Apache or IIS, Internet Information Server. All right, and those guys speak the HTTP protocol. Now, so I just made a GET request. Now, if I right-click on this and I say View Page Source, we get a bunch of crap. Okay, this is a bunch of HTML and JavaScript, and this is the result of me asking for something. So I requested a page, probably index.html. That's usually the default page. And it spit out the HTML and JavaScript associated with that. Now, if I go into Postman here and I make a request I make a GET request, which is the default request type for a web browser, and I make it to www.google.com, and I hit send, we should get very similar. We really should get the same data, but it's, you see it's really long. drawn out here. Okay, so this gives me that same result. That makes sense? All right, so typically we're not going to be making just clean GET requests like that when we're talking to a RESTful API. Nothing says we can't, but usually we're going to be asking for certain, we're passing in some parameters. A lot of RESTful APIs require us to authenticate with it. Remind me here, did we actually make a API key for this last time? Yeah, here we go. Did I create an app in class last time on Yelp? Yeah. All right, so you go to here, yelp.com/developers, and it takes you to their API, or just do a search for Yelp API, and it'll take you to this thing called Fusion. This is their Fusion API. This is their RESTful API for doing Yelp things. So this is how you can bring Yelp data into your application. All right, and you generate this API key, and this is like your super secret password you're going to need to authorize with Yelp. So let me go into the documentation here. So here's the various, let me go back one here. I think these are the endpoints, right? Yeah, so I can make a GET request here, and I can search for businesses. All right, so this would be an example of a GET request. So here's the Yelp Fusion. So here's my business endpoints. So these are the various questions I can ask. So an endpoint, we talk about endpoints in REST. Actually, it's really an API. API endpoint. This represents we might say a question that we are allowed to ask an API. This can be in the format of any of the 4 HTTP functions. Typically, if we want to retrieve data, it's going to be a GET request. If we're trying to write data, it's going to be a POST request. If we're trying to update data, it'll be a PUT request. If we're trying to delete data, it'll be a delete request. Make sense? Okay. But a lot of times what we're trying to do is we're trying to bring the data from, in our case here, Yelp, into our application. So a pretty high percentage of our requests are going to be GET requests. Show me all the restaurants in Mequon. Something like that. Okay. So we go back here. Here's our endpoint. So I'm doing a business search. So this endpoint returns up to 1,000 businesses based on the provided search criteria, which are these parameters. All right. It has some basic information about the business, blah, 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 blah. Okay, if you want to get reviews, you can go to, businesses / whatever the ID for the businesses / reviews, and we'll kind of look at some of that stuff as well. All right. So this is the GET request that we want to make. Now, if we go to a web browser here, and I paste that in, I've already mentioned that GET is the default request that web browsers make. So I press enter, it's going to yell back here and say, validation area, authorization is required. Okay, they want us, did I go over authorization last time? Or didn't quite get to that?
You said the header?
Yeah, the header stuff?
You did the header stuff.
Okay, so I'm kind of reviewing that, that's okay. But basically, they want us to have previously agreed with them. Sometimes you pay for it, sometimes they just want to know your contact information and stuff like that, that we're allowed to access their data, and they've provided us some sort of means of authenticating with them. Okay, so I can't conveniently do this with the web browser. You technically can use the developer tools to fake it, but that's where Postman comes in for testing. Postman allows us to test our queries outside of code so that when we go to code, we know we're asking the correct questions. So I'm going to show you both sides of it. So we use Postman to make sure we get the parameters and the authorization, stuff like that right. Then we'll write the code that accomplishes the same thing and gets the same data. Then we'll pull apart the JSON because it's going to give us this bunch of JSON stuff that we'll see here in a second, and we need to be able to programmatically parse through that and pull out the names of a bunch of restaurants, the addresses of those restaurants, the list of the reviews of those restaurants, stuff like that, because it's going to give those to us in a JSON object that is built in terms of all of this crap. Kind of make sense? I cannot emphasize enough from your career perspective how important the stuff we've done last class and today is to what you will be doing on a day-to-day basis for the next 20 years of your life. Right? So there was like a collection of classes to like pay attention to. You should pay attention to all of them, but if there was a collection of classes, these would be up there. Here's what I'm getting at. Okay? So this guy's yelling at us saying, hey, you need to provide us some sort of authorization before we're just going to start handing you data. Typically, that's going to come in the form of an API key. That's kind of the go-to move most of the modern RESTful APIs use. It's not like a, historically, it could have been a username and password. It could be all sorts of different things. But now they kind of give you an API key and say, look, give us this crazy-looking string, put it in one of the headers you're using to make your request. And as long as you've given us something we recognize, we're going to work with you. All right. But the other thing is that API key links it to us. So a lot of times, at least when you use an API for free, some APIs charge you. But most of them at least have a developer access to the API for you to write applications. And then once you turn your app live, you then have to start paying, because what they do is they artificially put a limit on you for the number of API calls you can make per day on the developer one. I mean, it's not anything like horrible, and you might be able to make 5,000 calls in a day. So you would have to like accidentally write an infinite loop to make too many of them. But actually what happens is a lot of them, what they do is they limit the number you can make like per second. So maybe they say you can only make 3 API calls per second or something like that. And imagine if, let's say you had an app that was using PayPal and you were using your developer API key for talking to that, and you had 100,000 people with your app. Well, only 3 of them per second could actually make an API call. So you kind of see how they limit you. They're not limiting you in a real way from a development perspective. You know, it should be plenty flexible for you as a developer to do stuff. But once you turn it and you release it into the wild, they want to encourage you to use their tools. But once you release it into the wild and you're starting to make money, they want to start making money. All right, make some sense? All right, but this guy's yelling at us saying, hey, we need some authorization. So we go back to the documentation here, and we see that we have a header thing we need to put in there for authorization. And then we need to put the word bearer followed by our access token. So I'll go back into Postman here. And notice here we have a thing called authorization. Oh, I already put it in here. So we put the key as authorization. And notice the type. We have a bunch of different types, but I've mentioned that the common one, call it 95+%, will be API key based. Okay, they make you go through the thing on their website to prove who you are and things like that. Finally, they hand you this crazy looking key that would be pretty hard to brute force attack this. You know, that's looks like a pretty random string. All right, so they finally hand you that guy. Sometimes you require a client ID too. That would be more for like what's called OAuth authorization, but that's not really common anymore. That's probably not the fairest statement, but let me get away with it for right now. If you're talking to banks and stuff, they're probably going to want a little bit more than an API key. So the more secure the data that you're working with, the more kind of important that stuff is. The higher level of authentication, they're going to make you more hoops you have to jump through to talk to it. Okay, but if we just think about our daily stuff, Google Maps, Yelp, things like that, API keys all day long. Okay, so they want us to add a authorization header. So we put the key as authorization, and then they want the format of the value for this guy. This is just a name value pair, just like any other name value pair. They want the thing to have the word bearer, followed by a space, followed by our crazy looking key. All right, this is Yelp's way for you to authenticate. They say, we want an API key. You're going to give us, the key is going to be called authorization, and then we want you to give us a value that is going to be the string. That's the word bearer, space, crazy API key we handed you. Make sense? Once we have that, then we can make that same call that we tried to make up here where we got this error. And I'll go ahead and put that same get request in here. Yeah, we'll just leave it like that. And I'll go, I don't think I have any parameters in there right now, do I? Good, okay. I'll go ahead and hit send. Okay, so notice we got a different error now. No longer is it complaining about authorization. It's cool with that. Now it's saying, you need to give us a couple of parameters in order for us to give you a list of businesses. Effectively, we're just saying, Yelp, give me 1,000 businesses. No location, no, I'm not asking for restaurants or dry cleaners or anything. Just give me businesses. They're not going to play that game. They want us, they're saying, give us a latitude and longitude. Okay, now that's the kind of the first error they have. That's probably based on some if-else statements or something like that. If we go back to the documentation here, here are the possible strings we can give them. So we can give them, these are all name value pairs for the location. So we can give them a location. Maybe we put Mequon, Wisconsin. Okay, so go back to Postman here. So I'm going to click on params. And what this is going to do is it's going to build a GET request with these params. And what you're going to see is it's going to continue to put stuff out here. It's going to put like a little question mark, and then it'll say location equals Mequon, Wisconsin, so on and so forth. So usually it is Mequon plus sign Wisconsin, I think is what they'll end up putting. So I'm going to put the key it's looking for his location. This is just a variable name, so you have to match it. Case sensitive and all. This guy is asking me for a variable named location, and he wants a value of type string. So I'm going to say location. Now I'm going to type in Mequon, comma, Wisconsin. That should probably be okay the way it's going to put it in there. So it's building that for me. Then it wants, let's start with that. I'll just do a send. All right, so we get some stuff. So it's giving me a default list of businesses for Mequon, Wisconsin. Notice here, this is a JSON object. So here's our, so the top level, I've mentioned the root is a JSON object. So that means we have an open curly brace. Go back to our list here. Nuts and bolts. Root level is a JSON object, where a JSON object is an opening curly brace followed by 0 or more name value pairs followed by a closing curly brace. Here's our opening curly brace at the very top. Here's our closing curly brace at the very bottom. And in between, we have a bunch of name value pairs. Here's the very first name value pair. The name is businesses. And the value is a JSON array, because I see it in an opening square bracket. What do we put in here? We said, oh, what kind of values can we have in our name value pairs? Well, here, I'll actually throw one other thing in here. Names are always strings. So we have a string that's the name. That's like our variable name. So we have a variable name called businesses. And the value is going to be a collection of businesses, a JSON array. JSON array looks like opening square bracket followed by 0 or more comma delimited JSON objects. Go back in here. So here's businesses, opening square bracket. This is the JSON array. What do we expect to find in there? Comma delimited JSON objects. Here's the first one. What kind of object, what kind of value is that? That's a JSON object. We see the opening curly brace, a whole bunch of name value pairs. So we have ID equals this crazy thing. Alias equals this. Name is equal to the Cheel. This is a restaurant in Thiensville. Here's an image URL. So if we follow that image URL, it's going to take us to a picture that represents that guy. Whether or not they're currently closed. Review count, here's the number of reviews. So this is giving us a whole bunch of JSON data that When we go and we write our JSON parser, we use a JSON parser, we can now pull that information out and bring it into our application. All right, once we get to the end of this guy, so notice we have categories here as well, and the value for categories is what kind of value? JSON array. It's a collection of JSON objects. First JSON object right here is a collection of name value pairs, alias, and title. And then there's a comma after it. I mentioned it's 0 or more JSON objects separated by commas. So there's my comma. Here's the next JSON object. Here's the next JSON object. Here's the end of that collection, which is inside of this JSON object, which is inside of a collection. Next name value pair, rating is 4.5. Here's its coordinates. So you could plot it on a map. So I could take those latitude and longitude coordinates. I could pass it to the Google Maps API and have it pop open a map for me and do something with that. Kind of see how this is all connecting? How many apps have you been in? If you open up the Yelp app on your phone and you click the navigate thing, it usually takes you to Google, opens up Google Maps on your phone, and you'll navigate there. This is how all those apps are talking to each other. They're this kind of stuff. All right. So here's an example. We have transactions. So this is showing us the value is a JSON array, but it's an empty array. There are 0 JSON objects in there. So no transactions, whatever that means. Here's price. Here's the location. So we actually get address information for it. So location, the value of location is a JSON object. It's all the way to here, actually. That's the value of location. Name value pairs. The name is always a string. In this case, it's location. The value is a JSON object, which is an opening curly brace, followed by 0 or more name value pairs, followed by a closing curly brace. Starting to see the pattern? Starting to see the power of JSON? These things can be turned right back into objects. All right. So we have phone number, we have display phone number in case those are different. So this phone number here is what you might use to actually send to the phone application to dial it with the right country code and stuff like that. But you might display it. This is kind of a prettier version of seeing the phone number on the screen. And then it also gives you a distance from where you, I guess, currently are. I'm not sure what the value is. Giving me 2,173. I don't know what that is. I don't know if that's yards or where it thinks my location is. It's possible it thinks that I'm like at Yelp headquarters, so this might be miles. So Yelp headquarters is probably somewhere in California, would be my guess, Silicon Valley. So that would make some sense that this restaurant, the Cheel, is a couple-minute drive from Southern California. Oh, yeah. All right. So then we have the end of that first JSON object that was in our original collection of businesses up here. That's the end of that first JSON object, because businesses is our name value pair in our top level, which is a collection of JSON objects. The first JSON object was for this restaurant called the Cheel, followed by a comma. Here's the next JSON object. This one's for Cafe 1505. Here's the next JSON object. This is for First Watch. So it's giving a lot of restaurants, because that's kind of what Yelp is typically used for, is restaurants. That must be their default category. So on and so forth. Here's Mequon Pizza Company, yada, yada, yada. Make sense? Now we go back in here to our other parameters we can give this guy. We can, after location, we can also give it latitude, longitude. We can give it a radius from where we are. Maybe we say, hey, I want restaurants within 20 feet of me. Probably going to get a real slim list, but, whatever. You can give it categories. Here's a list of supported categories. So let's see if we have, let's look for churches. Do we get churches in here? Let's see how nice they are to the Lutherans. We have disc golf courses. I think it's under religion. Ooh, golf. Come back to that. Under a category here. Arts and entertainment. Hopefully they don't have it underneath that. Oh, that's a pretty good idea.
Hey.
Religious organizations. So we're going to say churches. Does it let us go deeper in under churches? No, just lets us do churches. So we're going to say, and this is for the top level guy here, the parameter, the variable name is categories. So we're going to choose categories for our parameter. So we already have location in there. Now we'll add another key. So we're going to do categories, and the thing was churches. All right. Now it'll be interesting. I don't know if churches is, I mean, the way they kind of read it, put it in there was that kind of, because of the way they had them separated, is that the default for churches must be Christian churches. Because I think they had mosques and synagogues and things like that as their own categories. So let's see what we get from this. All right, so notice up here, as they've built in these parameters, we have a question mark, location equals Mequon, Wisconsin. Then the ampersand, and categories is equal to churches. So now I'll do a send. This is giving me some more information. So this is going to show me businesses, and these are churches. So here's this is a JSON object. Name value pairs, we have exactly one parameter in here called businesses, which is a JSON array. See how we can consistently rely on what their data, how Yelp is giving us data. Inside of this, we have Trinity Lutheran. It's the first one that came up. North Shore Assembly, Christ the King Baptist, St. Eugene Congregation, maybe Catholic? What does it actually say? Maybe it says in here. Lincoln Park Lutheran, yada, yada, yada. Okay, so now instead of using the default category, which appeared to be restaurants, that kind of makes sense. I mean, that's not what we use Yelp for. Chances are, if you were like looking for churches in the Mequon area, Yelp wouldn't be your first stop. Okay, but they're there. They've collected data. They're there. It's like, well, your Yelp review. Wouldn't that be funny? You walk into a church and they're asking you for Yelp reviews. Find us on Yelp. Review and comment. All right, so we're kind of getting the point here. I can make a call to an endpoint. I have to authorize with Yelp in order to talk to their data, but I can make a call to an endpoint. I can provide it inputs, parameters, so that I can get kind of a filtered version of the information I want. All right, that makes some sense? All right, so let's start with this. I'm gonna, let's see. Well, here we'll change my category to golf. What do I get out of that? Missing links beginner should go there. Wisconsin Club, that's not even the next closest thing. Dreska Park, that's even farther away. Yeah, don't look for golf courses on Yelp either, apparently. All right, but for us, restaurants is probably that's what we use Yelp for. So we'll use that as our example here. All right, so ultimately, this is the GET request we want to make in code. We've looked at our couple of parameters. We've confirmed how their authorization works. So we've used Postman to do all that work ahead of time. Make sense? Now we can say, I want to bring that JSON into my program. So what do we do? I'm going to go, did I create a new project already?
No.
Okay, so I know we had one for the cave crawler. Just for time here, let me actually steal a little code real quick. I'll explain what the code does. But I did this earlier. We talked about threads in here either?
No.
All right, I'm just going to show you all this. I'll just rewrite it. I'll rewrite that part. All right, so let's start a new Android project. We'll do empty activity. Let's call this guy CSC300 Yelp example, something like that, or Yelp API. All right, we'll go ahead and hit finish. This will open up. Now, one rule, this is more of an Android rule, because we haven't done any network requests in here with Android, right? Okay, so let me just throw this out here. Android has some rules associated with it. You cannot make a network call on the main thread. The main thread is used for our normal logic and all of the interface stuff. They effectively say, we want the interface to feel as clicky as possible. You know, when you click a button, we want something to happen. When you scroll, we want it to feel smooth. So they're saying, look, we'll let you do normal logic in there. We'll let you do your interface updates and stuff like that in there. But if you're going to start doing things that might take a random amount of time, for instance, how long is it going to take for us to ask Yelp, read in a bunch of data, get that data, parse that data, do something with that data? That's not necessarily an instantaneous type thing. It might be half a second, it might be 5 minutes, depending on the amount of data and how slow the network is and all sorts of stuff like that, right? So they're saying, to protect the interface, we're going to make you do that on a separate thread. Okay? So, about to tell you. Ask and you shall receive. So what's a thread? This is a, how many of you have had the operating systems class? Okay, so in there you talk about processes and PCBs, process control blocks. And so a process, every single time you have a computer, so here, I'll just go out to the terminal here real quick. Clear this, I'll type in top. This is gonna show me, this is all the running processes that are currently on my computer. All right, so each of these is a process. Notice it has a PID over here. This is the process ID. So this is the unique, kind of social security number of each of the running programs on my computer. You can think of a process as like a program, okay? But these processes, they get their own chunk of memory, their own scheduling time on the CPU. So, my machine here has a quad-core CPU in it, so I can technically do up to 4 things at once. Technically, it has hyper-threading, so they would claim it has 8 logical processors, so you can sort of kind of do 8 things at once. When you take the architecture class, we'll talk about that. Don't worry about that. But punchline is, every program that's running our computer is a process. But processes are considered heavy, okay? In that, they're an object that has a whole bunch of stuff thrown in it, and the operating system can work with those processes on an individual basis. So it works with the web browser to schedule when it gets CPU time. It works with Microsoft Word to schedule when it gets CPU time, so on and so forth. Now, a thread is a lightweight version of that. A thread is saying, look, we know you already live inside of a single process. Like we have our Android application here, which is one program, one process running on the computer. Now, you might want to do some things sort of kind of simultaneously within the scheduling time that process already has on the CPU. So maybe that process is getting 2 seconds on the CPU, just making up a number, okay? And maybe we say, you know what, we're gonna let the operating system go ahead and give our threads for this application a little bit of that 2 seconds to get something done, something like that. Okay. The main thread is still the highest priority. We want our interface to feel, scrolly and clicky and all that stuff, but we'll go ahead and let the operating system schedule those threads on the side so that we can get some stuff done in the background. Because we don't necessarily care if our data takes, a half a second or 3/4 of a second to get our JSON, if we're not relying on it necessarily to be instantaneous. We do care when we click a button, we want it to execute right then, right? But the amount of time that's happening in the background, if our app is still working, we don't necessarily care about. We'd rather our app feel like it still works. Okay, so this makes sense what a process is. And then a thread is a lightweight version of that, lightweight process that is scheduled alongside its parent process. I won't quiz you on this. This is a question I'd ask in an operating system exam. CPU scheduling would be operating systems, all that stuff. All right, but I'm just telling you what a thread is, what we're about to programmatically create. We're about to generate a thread here that will have something happen. So from a programmer's perspective, so for programmers, this allows us to have something happening in the background in a non-blocking, asynchronous way. We've seen those words before. Non-blocking, asynchronous, that's kind of like our Firebase stuff. Mm-hmm. Like, hey, give me some data. Let me know when you have it and I'll work with it. They're implementing that with a thread, I promise you. Okay, now we're going to do something with threads on our own. Cool? All right. So if we look at the documentation for the thread class, what we would find is that threads implement an interface. What's an interface? Remind me. We've used one before. Used at least one recently. They usually have an able at the end of it. ABLE. So we've used serializable, right? So interfaces are like a class, but rather than implementing a solution, they dictate how an object must work. For instance, serializable dictates that all fields must be public. We have an interface called runnable, which the thread class uses, dictates that we must have a public void run function. Okay, that's what it dictates. So if we forget to put that function in there and we said we've implemented runnable, it will scream at us. All right, now we don't necessarily need to worry about the implements runnable thing here because we're relying on an additional level of magic. So we have the Java thread class. Public class thread implements runnable. So what does that mean? The thread class has a public void run method. How do we know that? How do we know that it must have a public void run? I just called it a function on the other screen, so we'll keep that. How do you know it must have a public void run function?
Because it implements runnable.
Because it implements runnable. And runnable enforces that. Runnable dictates that anything that implements runnable must have a public void run function. So if I'm telling you that the thread class implements runnable, it definitely has a public void run method. Got it? So thread class has a public void run function that does nothing. Probably not what we actually want. All right, so we probably are going to override that function, write our own version of our run method to do what we want our thread to do when we run it. All right, now why extend thread rather than implement runnable ourselves? Now we've kind of talked about that threads and processes, these are pretty close to the operating system. Mm-hmm. There's some magic that has to happen behind the scenes. There's communication that's happening between the Java virtual machine and our operating system and stuff like that that we do not have direct access to. So if we need something to behave like a thread, which is an operating system level system call, We talk about this stuff in the CSC 450 systems programming class, which is next spring. 470s in the fall.
Yes.
Everybody get enrolled in 470. You want that class, trust me. It'll help you get a job. 450, I think, would be very good too. We do a lot of this kind of stuff in there. So why extend thread rather than implement runnable? Well, because we're having to communicate directly with the operating system, we're kind of reliant on some magic. So the thread class has a magical start method that does whatever is needed behind the scenes to create a thread, ask the OS to schedule it, and ultimately call the public void run function of that thread. So it's a little bit more than just writing some logic inside that run function. We're going to create a thread, and then we're going to tell that thread to start. And starting that thread is going to do several things, and then call our run method automatically. Make sense? So we don't want this guy to just be a plain Jane function or plain Jane object that has a run method. We want him to behave like a thread, and we don't really know how to do that. So we're going to rely on the Java virtual machine to take care of that heavy lifting for us. Make sense? All right, so the good people at Java, at Sun Microsystems, now Oracle, they've given us this nice class called thread that is super easy to use, and it just says, look, you want something to be a thread? Just extend thread, which implements runnable. If you just extend thread and do nothing else, it'll work, but it won't do anything. We'll create a thread. We'll call the run method that currently does nothing. No harm, no foul, except you're scheduling a thread that does nothing, wasting a little CPU power. Okay, but what we're going to do is we're going to come into our code here. I'm going to right-click. We'll create a Yelp API class. So Java class, Yelp API. Okay, this guy's going to look like this. Now, right off the bat, I'm going to say that this guy extends thread. All right, so he is a thread, which implements runnable. Now, we're going to say, you know what? I want this guy to do something special for his run method. So we're going to say, if we want Android Studio to do the override for us, we actually technically don't need to override it. We can just write it ourselves, and the language itself will say override. But if I want to just say the run method here, and I want to write my own version of this, and I press enter, it'll create public void run, put the little override, blah, blah, blah behind it, which gives it a little bit better performance. Okay, it calls super.run by default, but we don't need to worry about that. That doesn't do anything, so I can actually leave this blank if I want. So I will. I already advertised that run method doesn't do anything. Just says, hey, I'm a placeholder because I'm a thread. I implement runnable. Runnable said I had to have this guy. So I wrote it, put nothing in there. That way it stopped screaming at me. But we're going to override that run method ourselves to do some stuff. And I copied a bunch of code from that other screen. It just imported a bunch of crap for me. So I'm using something, a JSON array, JSON object. We learned about both those guys today. Okay, so these are built into Java. It's a project called org.json, JSON array. We know what one of those guys is. We have org, JSON, JSON object. We know what they are. These are the Java implementations of those things. Okay, that we can ask, say, hey, give me one of your name value pairs. Give me the first element of your collection. Give me the second element of your collection. Kind of with me here? All right, we're going to use this HTTP URL connection. We know what HTTP is. Okay, a URL that is fancy schmancy name for this dude up here. This is URL. Universal Resource Locator. Fancy way of saying what website do you want to go to. Okay. So here, if you want me to toss that in the notes, just so you have it. URL universal resource locator. Fancy way of saying the string that represents a website, or in RESTful terms, endpoint. Cool. All right, so nothing crazy there. And then we've seen scanner before. That allows us to read something in. We've read in from a file. We read in from input streams, right? We've read in from input streams. So we've created an input stream that's the keyboard. We've created an input stream that was to a file. Now what are we doing? We're creating an input stream that's talking to Yelp using the HTTP protocol over the internet, talking to a RESTful API, passing it a bunch of crap. Make sense? So here's my, let me cut and paste a little bit here because I actually, I can just do that. Then I can get rid of that and then paste that. Okay. I had a run inside of a run because of what I copied from the other screen. All right. So now we have to put this inside of a try catch. We've dealt with exceptions before, right? We've had to do it for like file not found exception when we did file IO. So we have, just want to throw into the notes again real quick. There's something called exception handling. The tool we use for this is we try, opening curly brace, we'll just say dangerous code, closing curly brace, catch, opening parenthesis, exception E, opening curly brace, handle it gracefully, closing curly brace. That's what a try catch is. We're going to say, we're going to try to do some stuff that might cause a problem. If something happens in there that's bad, we'll catch that exception, and then we can gracefully handle it instead of our application crashing. All right, so punchline here is whatever URL I put in here, it might not work. Our internet might be down. Things could go wrong that might cause me requesting this JSON, requesting information from this endpoint to not work. All right, so I'm going to go ahead and we're going to call this guy, what are we doing, restaurants? We'll call this guy business endpoint. And this is going to be a call to yelp.com, blah, blah, blah. Actually, here, we'll go into our, so this is our URL, right? That we're going to put in there. So we've tested it, and we're happy with that URL right there. Okay. Then we're going to make an HTTP URL connection. So we're opening an HTTP connection someplace. I'm going to call that con. And this is my business endpoint. So this is going to be a business endpoint.open connection. And this is going to open a stream. Specifically, it's going to be HTTP URL connection. Let me show you something here. So if I just do a HTTP URL connection, open up the documentation here. That guy is a URL connection, which is an object. So actually, this doesn't give me the input stream yet. So this is just an object for holding information about a URL. All right, so this gives me a connection. Now I'm going to set some properties. Does this look familiar to you? So I'm setting a header. So I'm setting a request property named authorization. Its value is bearer, followed by a space, followed by our crazy string. Cool. Then I'm creating my scanner. I'm going to ask for my connection to get me its input stream. That's when it actually opens the connection over the internet. I'm going to create a little string here to store my data. And as long as my input stream has more stuff in it, as long as there's more JSON for me to read, I'll tack it onto my data. As soon as I'm done, I'll close my connection over the internet, and I'll go ahead and print out my data. Just start with that. So I'm going to comment out this other stuff. All right. So ultimately, I'm just going to print out some asterisks followed by data followed by what should be this JSON. Make sense? If everything I tested here was set up right, and I created the programmatic equivalent to it here, I should get that same JSON. So we'll go ahead and run this.
Does it just run automatically? Do we have to call run somewhere?
Thank you. Probably need to create my thread inside the main activity. So I've written this object here. We'll let our emulator boot. So here inside of main activity, I'm going to go ahead and I'm going to create a instance of Yelp API. And this guy will be equal to, all caps, Yelp API, all caps. This guy will be equal to a new Yelp API. Didn't have a constructor, so this will just take normal stuff. And then I'll just say Yelp.start. That's that magical function I mentioned earlier that does whatever it takes to generate a thread and then calls the run method. And what does my run method say to do? My run method says, open up this connection, read in the JSON, print that JSON out. Got it? So if everything works out well, what we have in Postman right here, the same JSON that we got here, should be retrieved by our Java program. And because I've put it inside of a thread, we're following Android's rules of saying you can't do network stuff inside of the main thread. We'll go ahead and run this. Open up our logcat down here. Put some asterisks in there. Oh, I have to give it internet permission. 1 second. So we have this security exception for Android. We need to add permissions to it. Let me just do so I can get the right thing. It's in our manifest. Yeah, so this guy right here. So this goes inside of our Android manifest. So we have to give our app permission to talk to the internet, is what we're doing. So I go into app, go into manifests. That's this guy right here. And I think I can put it anywhere I want in here. I can put it before this guy. So just say uses permission, android.permission.internet. Now when I run it, I think it should work. Okay, doesn't like my string. I'll fix this. It takes 2 seconds. Because we have a kind of a malformed URL here, I'm going to put a little plus sign there for that guy. It did that behind the scenes in Postman for us. There we go. So there's our businesses, blah, 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 all this stuff. See how that's working? Pretty cool. And then finally I had a JSON object here where we read in the JSON object. We got the business's endpoint, which is a collection of JSON objects. Then I went through and extracted the name from each one. So that's your starting point for the homework. And there's all of our restaurants. Okay, so for your homework, we're going to create a list view that will give the name and the phone number for each of our, actually we're going to do name, phone number, and web addresses in here, right? Well, we'll just do name and phone number, keep it simple. So we're going to create a list view that gives me the name and phone number of all the restaurants near Mequon. If you're going to the senior. Oh, if you went to the hackathon last week, you can choose not to do the phone number, which does save you quite a bit of time because that means you don't have to make a custom array adapter. Right? Default array adapter will let you show one string, so you can make that string the name of the restaurant. But if you want to have both things shown, you need two text views, unless you figure out an alternative way of doing it. There is one, but I would encourage you to write a custom array adapter. Make sense? Questions, comments, concerns, bribes? Remember, senior seminar projects start tomorrow night, 5 to 10 p.m., and also Thursday, 5 to 10 p.m. I'm giving you extra credit for coming to each one you go to. What was it, a 0.5% per presentation you go to? There'll be sign-ins. Today, student, faculty, staff, Bible study, God in, grub, sign in, get your tray, take it down to the terrace room from noon to 1.
Is it less this year?
Was who?
Because last year you gave us 10%. This year
The maximum you can get is 8%.
last year was 10%.